Imagine it's 1945. World War II is drawing to a close. In a top-secret Raytheon lab, self-taught engineer Percy Spencer is about to take a step that will change every kitchen on the planet, though he doesn't know it yet. He stands before an active magnetron, the heart of British radar technology. In his pocket lies an ordinary chocolate bar, about to become the detonator of a domestic revolution. And this revolution won't begin with an explosion, but with a sticky stain on his trousers. Percy Spencer was no typical scientist. He left school at 12, but his innate engineering talent made him one of the nation's leading experts in radar technology. This isn't a story about an academic in a white coat, but about a practical man whose hands and mind were his primary tools. It was precisely his practical mindset that allowed him to see what others missed. By the end of his career, over 300 patents would be registered in his name. This man wasn't just an engineer, he was a walking idea factory. So what is a magnetron? It's a powerful microwave generator. Its purpose was to send out radio signals that, reflecting off enemy aircraft, allowed them to be detected. This device could locate targets dozens of miles away. But no one suspected it possessed another culinary superpower. The magnetron was so vital that the British handed it over to the Americans in 1940 as part of the highly classified Tizard mission, calling it the most valuable cargo ever to reach our shores. It was the heart of the Allied air defense. Spencer is working with the magnetron switched on. Suddenly, he feels a strange warmth in his pocket area. Not scorching, just unusual, unexplained. He pauses, runs his hand over it. No fire, no visible heat source, only the humming apparatus in front of him, and complete bewilderment about what's happening. He reaches into his trouser pocket, and his fingers sink into something warm and viscous. It wasn't the solid bar he'd placed there that morning. It was a shapeless, sticky substance. Legend has it that it wasn't just chocolate, but a peanut cluster bar. The most powerful Allied military technology, and a melted peanut dessert. This accident could have remained just an annoying stain on his pants, but not for Spencer. Most of us would simply curse the ruined clothing. But Spencer froze. His engineer's brain instantly connected the dots. Active magnetron, strange warmth, melted chocolate. He saw not a problem, but a phenomenon. It was his eureka moment, not in a bathtub, but in the middle of a lab smelling of ozone and burnt sugar. This is a classic example of what Nobel laureate Daniel Kahneman would call switching from System 1, our fast, intuitive thinking, to System 2, our slow, deliberate thinking, to slow, analytical thinking. An ordinary person would remain in System 1, annoyance. Spencer instantly activated System 2, analysis. Now, pause for a second. Imagine yourself in his shoes. Your reaction? Annoyance over ruined clothes and a wasted snack, or a burning, all-consuming curiosity? The answer to that question. That's the fine line distinguishing an ordinary person from an inventive genius. Spencer chose curiosity. His brain was already running at full speed, ignoring sticky fingers and ruined trousers. He immediately formulates a hypothesis. Invisible microwaves emitted by the magnetron were somehow directly affecting the food. They heated it from the inside. It sounded like science fiction, like something out of a Flash Gordon comic. But if it were true, he had just stumbled upon a completely new physical principle, a principle with unimaginable commercial and domestic potential. He needed proof. The next day, Percy Spencer came to the lab not with blueprints or tools, but with a paper bag of corn kernels. His colleagues probably looked at him with bewilderment. He wasn't going to fix radars. He was going to make history. He was going to prove his crazy theory. And to do that, he decided to cook the world's first food using radio waves. He places the paper bag in front of the magnetron's emitter, switches it on. A second of silence, and then the kernels begin to tremble. They jump, pop with a crackling sound, turning into fluffy white popcorn that scatters across the lab. It was like magic. Spencer's colleagues, full of skepticism just a minute ago, watched with open mouths. The hypothesis was confirmed. It was proof you could eat. But Spencer needed more. He decided to raise the stakes. He took a raw egg and placed it in a kettle to focus the wave energy. One of his colleagues, an engineer named Radarange, peered curiously into the kettle's spout, trying to see what was happening inside. He became the first person injured by improper microwave use, because in the next second, the egg exploded. Hot yolk splattered across his face. It was both dangerous and a little comical, and it conclusively proved this new force was incredibly powerful. Now, imagine yourself in Radarange's position. You're watching distrustfully as your boss brings an egg to a strange military machine. And the next second, hot breakfast flies into your face. You'd either quit or demand a raise for participating in a historic discovery. That exploded yolk became irrefutable proof. It showed that microwaves could cook food absurdly fast. Raytheon acted swiftly. They recognized the scale of the discovery. On October 8, 1945, they filed an application for a process for treating foodstuffs. This historic document received U.S. patent number 2,495,429. Percy Spencer, as the inventor, received not a cent in royalties, only a symbolic bonus of $2. This wasn't a mockery, but standard company practice for employee patents, a formality that seems absurd today. Spencer and his team built the first working model. It was a simple metal box where radiation from the magnetron was directed. They understood. They held not just a scientific curiosity, but the future of cooking. But transforming cumbersome military technology into a safe kitchen appliance proved far more difficult than exploding an egg. Their first creation was a true monster. In 1947, this monster received a name, Radarange. It stood almost 6 feet tall and weighed 750 pounds. Imagine a refrigerator for a giant. This wasn't a kitchen appliance, it was more like an industrial machine. It required a separate water supply for cooling, like an old car engine. You didn't just buy it, you installed it in your kitchen, like a heating boiler. Place a modern microwave next to it, it would look like a toy. The cost of this machine, $5,000. In today's money, that's over $50,000. To put it in perspective, in 1947, a brand new Ford car cost about $1,200. This oven cost as much as 4 new cars. No family could afford it. Therefore, the first buyers were not housewives, but restaurants, galleys on warships and hospitals, places where speed was more important than price and size. But even if you could buy it, you'd be scared. The main problem was public opinion. People feared radiation. The world had just entered the atomic age. People's minds were filled with fear of an invisible threat after Hiroshima. Any radiation was automatically equated with mortal danger. The microwave became a victim of nuclear psychosis. Newspapers were filled with headlines about radiation sickness from a heated sandwich. Fear proved stronger than convenience. Ultimately, the Radarange was a commercial disaster for the domestic market. Spencer's ingenious invention became a cumbersome, frighteningly expensive box that no one wanted. The story could have ended there, with the microwave remaining a niche industrial device. But took shape in 1965, and it wasn't a new flash of genius, but cold corporate calculation. Raytheon bought Amana Refrigeration. At first glance, a strange union, a military radar manufacturer and a refrigerator manufacturer. But it was a brilliant strategic move. Amana had experience in creating home appliances. They knew how to talk to consumers. But most importantly, they were pioneers in manufacturing home freezers. Amana understood the burgeoning market for frozen foods and convenience meals, and the microwave was the ideal accelerator for this world. Raytheon engineers were given a clear task: create an oven for the home, compact, affordable, and not frightening. The main enemy remained the magnetron. It was the heart of the technology, but too big and hot a heart. It required water cooling, like a truck engine. Engineers spent several years completely rethinking it. The result was a new, compact, air-cooled magnetron. This was the technological key that opened the door to the ordinary kitchen. No more need for plumbing. No more need for a separate corner the size of a closet. The technical barrier was broken. Let's assess the difficulty of this task. On an innovation breakthrough scale from 1 to 10, where 1 is attaching wheels to a suitcase and 10 is building a thermonuclear reactor, the task of shrinking the microwave to the size of a television was a solid 8. This was not a simple improvement. It was a complete rethinking of a key technology, a true engineering feat hidden from the public eye. And so, in 1967, the result of this work appeared on store shelves, the world's first countertop microwave oven. It cost $495. That's about $4,000 in today's money, still expensive, but comparable to the price of a color television. And crucially, it fit on a kitchen counter. This historic appliance was called the Amana Radarange RR1. It was this name, not its cumbersome ancestor, that became synonymous with the home microwave oven. The domestic revolution, which had failed 20 years prior, finally began. But to understand this revolution, you need to look inside the box itself. How does it work? Imagine that the water molecules in your food are tiny compasses. Microwaves create an ultra-fast alternating magnetic field that makes these compasses spin wildly. This friction generates heat. It's not magic, it's physics. A microwave is an invisible fire that ignites food from within. To be precise, this field changes polarity 2.45 billion times per second. That's like forcing a water molecule to do a somersault almost 5 billion times in 1 second. No wonder food heats up so quickly. This invisible fire changed not only dinners, but society itself. It spawned the frozen convenience food industry. The pace of life accelerated. Food preparation ceased to be a multi-hour ritual. This freed up time, primarily for women, and became one of the catalysts for their mass entry into the workforce. By 1975, microwave oven sales in the U.S. surpassed gas range sales for the first time. This was a turning point. By 1986, 25% of American households already owned a microwave. The revolution became irreversible. But the fears didn't disappear. The main myth: microwaves make food radioactive. This is false. Microwaves are non-ionizing radiation. The same as light from a bulb or your radio signal. They cannot change the atomic structure of food, and safety is ensured by the metal mesh on the door. This is a Faraday cage. It works like a mosquito screen on a window. It easily lets light through, allowing you to see your food, but reliably blocks the massive compared to light microwaves. They remain trapped inside. A modern microwave is one of the safest appliances in the kitchen. Spencer's legacy proved to be much broader than the kitchen counter. Today, microwave technologies are the invisible foundation of our world. Your Wi-Fi, your mobile communication, industry, medicine, all are a direct consequence of that accidental discovery that began with melted chocolate. Even in chemistry, microwaves have revolutionized processes. Microwave synthesis allows reactions to occur thousands of times faster than traditional heating. So Spencer's chocolate bar accelerated not only our dinners, but also scientific discoveries. It was the most influential dessert in human history. So what can we learn from this story? This is not just a tale about a chocolate bar. It's a step-by-step guide to creating the future. Here are 3 lessons from Percy Spencer. First, cultivate observational skills. Most of us would simply curse the ruined trousers. Spencer, however, saw an anomaly that demanded investigation. Remember, pay attention to the small things that don't go according to plan. It is in these glitches that true discoveries are hidden. As Louis Pasteur said, chance favors the prepared mind. The chocolate could have melted in anyone's pocket, but only Spencer's prepared mind saw something more than a ruined dessert. Second lesson, test your hypothesis immediately. Spencer didn't write reports or wait for permissions. The next day, he brought popcorn and an egg. You have a crazy idea. Don't put it off. Do the simplest test right now. Speed of verification is more important than perfect preparation. And the third lesson, be ready for the failure of the first version. The first Radarange was a monstrous failure. Success came only after 20 years of iterations. Your first version of a product, of an idea, will almost always be terrible. This is not the end. It's the beginning of the journey. This journey is a hymn to serendipity and curiosity, but it leaves us with a central question. What was the decisive factor in this great discovery? Was it the brilliant insight of one man, a unique mind capable of seeing wonder in melted chocolate, or was it simply the inevitable result of technological progress, just a matter of time before someone else stumbled upon the same phenomenon? What was key in this story? The man or the moment? Write in the comments just one word that, in your opinion, was the most important: genius or serendipity.